In this video, I want to talk about the absolute value and equations that involve absolute values. So first things first, we need to recall the definition of the absolute value and what that does. An alternative word for absolute value is the modulus. So we can take the absolute value of something, we can take the modulus of something. And doing that is about finding the magnitude or the size of something. So for example, what we're talking about is that the positive or negative, the sign of it is irrelevant. We're interested in the size of it. We can also think about the absolute value of a number as being how far it is away from zero. So for example, the absolute value of -3, the notation is here. Straight lines, bars either side of the expression or the value you're trying to take the absolute value of. So the absolute value of -3 is essentially asking you to think about how far away is -3 from zero. And we've dealt with quantities like this before, talked about the magnitude before, and we've talked about displacement versus distance. So displacement is distance with direction, and whereas distance is the magnitude or the absolute value of the displacement. So for example, if something has displacement of -5, that could mean that it is 5 units to the left of the fixed point, but its distance away from the fixed point is 5. The magnitude or the absolute value of the displacement is 5. So what we see here, if we think about this absolute value of -3, is asking us how far away from zero is -3. So obviously here's -3 back here, and this distance between -3 and 0 is clearly 3. What we also note here, obviously, is that the absolute value or the modulus of +3 is also 3. Both of these things are 3 units away from 0. So we get this, that the absolute value of -3 is 3, but also the absolute value of 3 is 3. Essentially what the absolute value signs or the modulus signs do is make whatever's inside them positive, or negate any negatives that are in there. So now let's think about solving equations involving absolute values. So I've got a really simple equation here, and in fact we've pretty much already solved this equation because on the previous slide we've thought about the fact that the modulus of -3 is equal to 3 and the modulus of 3 is also equal to 3. So thinking about this equation, what this equation is really asking us for is that the modulus of x is 3. So something is 3 units away from 0. What could that something be? And we know that that could obviously be +3, but also -3. So x could be +3 or -3. The modulus of both of those things would be 3. Okay, slightly more complicated equation. So the modulus of x minus 2 is equal to 5. So we can think about this quite logically, and the solution here is fairly obvious once you understand how to think about absolute values. But we can also deal with it more algebraically. We'll do it both ways. So the left-hand side of this equation, we have the modulus of x minus 2. So we're subtracting two things, so we're finding their difference, and the modulus signs will make that difference positive. So it means that the order that we do the subtraction in is irrelevant. This could be the modulus of 2 minus x, and it would be the same equation. So what we have here is that the difference between x minus 2 is equal to 5. That's what this equation essentially says. The difference between x and 2 is equal to 5. So essentially what we're looking for here is what number is 5 units away from 2, or what numbers are 5 units away from 2. So 5 above 2 is 7, and 5 below 2 is -3. We can check our answers by substitution. So if x were to equal 7, 7 minus 2 is 5, the modulus of 5 is 5. If x were to equal -3, -3 minus 2 is -5, the modulus of -5 is 5. So both of these are solutions to this equation. We can also think about this a bit more algebraically, and this becomes easier once the expression inside the absolute value signs gets a little more complex. So what we have is the equation modulus of x minus 2 is equal to 5. So if we think about what those modular signs do, they make whatever's inside them positive. And in this case, they make whatever's inside equal to positive 5. So what we know is that the modulus of something has to equal 5, which means that the something inside those modulus signs could either be 5 or the thing inside those modulus signs could equal negative 5. Both these things would make this equation true. And so then we have two simple equations to solve. Adding 2 to both sides gives x equals 7 and x equals negative 3. And we get the same solution we obtained by a slightly different method earlier. So now let's think about this. This is a little harder to interpret in the way we did initially with the previous example. But if we rewrite this as x minus 4, we can now see that actually what we have here is that the difference between x and negative 4 is equal to 6. So what we're looking for here are numbers that are 6 units away from negative 4. So 6 above negative 4 would give me 2, or 6 below negative 4 would give me negative 10. Apologies. Again, we could also think about this sort of purely algebraically. So modulus of x plus 4 has to equal 6, which means that the thing inside the modulus signs on the left-hand side here could either be equal to 6 or it could be equal to negative 6. Subtracting 4 from both sides, x equals 2 or x equals negative 10 are our two solutions to this equation. Now when we get to this expression here, or this equation here I should say, this is much harder to sort of interpret. We could rewrite it as 2x minus 1 and try and think about the fact that the difference between negative 1 and 2x has to be 3. And that's possible, but it starts to get a bit complicated. So I'm going to jump straight to breaking this up into two separate equations. So the modulus of 2x plus 1 is equal to 3, which means that the 2x plus 1, the thing inside the modulus signs on the left, could either equal 3, because the modulus of that would be 3, or it could equal negative 3, because the modulus of that would also be 3. Subtracting 1 from both sides, dividing both sides by 2. Subtracting 1 from both sides and dividing both sides by 2. We get our two solutions to this equation. And so in general, we see that provided that a is bigger than or equal to 0, that's because the modulus of anything cannot possibly equal a negative value. So if we have the modulus of a function equals a, then that tells us that that function is either equal to a or that function is equal to negative a. We've only dealt with linear functions here, but that would apply for anything. So if we were dealing with modulus of x squared minus 7 equals 2, then we would know that either x squared minus 7 equals 2 or x squared minus 7 is equal to negative 2. And so adding 7 to both sides and taking the square root, adding 7 to both sides and taking the square root, in this case gives us 4 possible solutions. And once we start to look at the graphs of modulus functions and compositions of those functions with other functions such as quadratics, we'll start to see why we get 2 solutions with the linear and 4 solutions with the quadratic, etc.